And welcome back. Now I wonder how many of you can actually recognise this white thing on my desk here. I'll give you a clue. If you've got any kind of dog in the household, you might have one, or indeed if you go walking you might have one. Well, let's put you out of your misery. This is in fact an ultrasonic dog deterrent, I suppose you'd call it. What it's supposed to do is emit ultrasonic or near ultrasonic sound from here, about 22 kHz actually, when it detects a bark. You can get different ones, of course. You can press buttons and it'll emit the sound, or like this one, as I say, it's sound sensitive. Except, of course, this one, which the dearly beloved bought in some cheapy shop, didn't work at all. Had zero effect on the dog we're currently looking after. And the idea, of course, is not to cause distress to the dog, but to make the dog understand that when he barks, he gets this very high-pitched sound that he doesn't like, and when he stops barking, the sound stops. Bit of training, pretty easy. It'd work on human beings as well, really, wouldn't it, if it was within the audible range? So I thought, okay, well, this doesn't work. Let's chuck it away. But just before I chucked it away, I thought, let's rip the thing open and have a look at what's inside. So let's do that in just a sec. There's a nice little circuit board in there, and well, circuit board, there's a link. Let's have a message from our sponsor today. PCBWay, PCB prototyping the easy way. For just $5 you can get 10 pieces, 1 or 2 layers. Ordering is easy on their website, and you can have delivery within 3 days. Try it now. And there'll be more on PCBWay in a future video. I'm going to do some kind of in-depth unboxing, because I've actually sent them off a circuit board I want them to make, so I can truthfully say exactly how I feel about it. That's for another day. Right, so this circuit board inside here then, let's have a quick look. Now this item at the top, that's not a standard loudspeaker, that is indeed a proper ultrasonic loudspeaker. It's not a pizza or anything, it's a proper loudspeaker. In fact, it might even come out with a little bit of persuasion. There we are. So there we are, there it is. So it is a high frequency loudspeaker, and because it's got a number on the back, I managed to track it down as well. So let's have a look at that on the browser. So there we are, that's the actual, well, it says the pizza tweeter, but in fact it's just a loudspeaker at the end of the day. Now the bad thing about this is if you scroll down a bit, you'll see the resonant frequency range. I don't know how you can have a resonant frequency range. It resonates at a particular frequency. I think it just means frequency range. 2.5 kilohertz to 50 kilohertz. Okay, that encompasses the sort of 22 kilohertz quite nicely for the dog thing. Operating frequency 25 kilohertz plus or minus 5. It's a bit odd, isn't it? It's sort of conflicting information here. But the worst thing is it says sound pressure level 90 dBs at 1 foot or 30 centimeters. That's at 25 kilohertz, which isn't very loud. Isn't very loud at all. So I don't think it'd be that effective, even if it had worked. And talking of working, then I looked at it, put it up to my oscilloscope, and immediately discovered that the chip they're using, which is the ubiquitous NE555, you can just about make it out there. Look, I'll get my pointer out in a minute. That's an NE555. As you can see, it wasn't connected up right. Pin 6 has got to be connected up to pin 2. So what I suspect is that underneath that chip there's a track that was either damaged or just missing or something. Who knows? But anyway, it wasn't working. As soon as I connected up pin 2 to pin 6 to make it into an astable vibrator, then it worked absolutely fine, and it delivered a nice square wave to here. Obviously square wave isn't the best. A sine wave would be much better, but to get a sine wave out of anything these days is quite difficult. So I got that working. Then I looked at all this bit of circuitry here and reverse engineered that and drew out the circuit and everything. And as you can see, I've soldered a resistor on there. Can't remember why I did that now. To get the gain up, I think. But basically it was all a bit of a pig's ear. Oh, telephone. So rather than try and get this working, I thought, well, I need to do this because I want to train the dog, at least partly. It's all right having a dog bark when someone's at the front door to let you know there's somebody at the front door, sort of guard dog syndrome, that's great. But when you say stop and it doesn't, then you've lost control, haven't you? So we need something else to reinforce your command and make the dog listen to you. So I'm going to chuck this, well, keep this, I might even desolder that chip actually, but all the rest is just a bit of a nonsense. So, get rid of that. What are we left with? Well, you can see something else on my desk here, and I've had this thing here for ages. Let me turn it around now. I only turned it around that way to stop you guessing what I was going to talk about. This is from Chemo from Germany, so all good quality stuff, we hope. And this is an ultrasonic generator, as it says on it. And if you take this apart, this has also got an NE555 inside it. But the biggest difference is it's also got a power transistor in there that will amplify it, so you get at least 115 decibels out of that silver cone speaker there, which is much better. Okay, and it's got a variable frequency range here from insects, dogs, cats, rodents and birds. And of course if you put it down to about rodents, you can just about hear it. Well, no, that's a lie. Let's take a step back. I'm getting on a bit, so my hearing is probably down to about the 11 kHz range. Can't hear anything above that. When I was much younger, of course I could. So I can hear it around about the rodents, and it does it like a siren. It goes up and down by about 5k around that area. If you were a child though, you'd probably hear it even at the dog and cat setting, which is 22 kHz. You'd probably just about hear it, especially as it's going up and down by those 5 kHz. What you wouldn't do is hear it at insects. So I thought, well, how can I use this then in our Arduino world so that it switches on intelligently, switches off intelligently, which is just as important, and use something to detect the sound and to basically use this for what it was meant for. Well, as you can see, I've got a few things on my desk here which I've been experimenting with. Let's look at this one first. This was something I had lying about. It's from the Far East, but you know, there's thousands of these about, different types. Basically, it's called an Arduino module sound detector. So basically, sound comes in here, it goes into this comparator here, and sends an analog signal out on that pin and a digital one on that when it exceeds a certain threshold, and you can adjust it via this screw. I've just put my hand behind it so it focuses correctly. There we are. Now, I didn't have much luck with this with another project I wanted to do years ago, so I just sort of put it back into the bin, really. Storage bin, that is, not the waste bin. And I got it out again, and exactly the same thing happens. It you just couldn't get the control you needed on this good enough, so I'm not going to be using that. So if you do want to experiment with one of these, go ahead, but just bear in mind that for a lot of applications, that resistor, that multi-turn resistor there, isn't particularly repeatable. So you might set it just right and you think, yeah, I've got it, but then after that you have to reset it again. So that's out the window. Then I thought, well, I've got some chips here. These are LM386 chips, and that's not going to focus again, is it? They're 8-pin standard LM386. Got them upside down now. This is the ubiquitous power module. You might find it in very small transistor radios or toys or something. It works from 5 volts to something like 12. In fact, rather than me guessing, let's have a look at the data sheet for this and see what we can find, shall we? So this is the data sheet then for the LM386 low voltage audio power amplifier, or low-ish I suppose, 4 to 12 or 5 to 18. The one I've got is the LM386M, I think, so or N rather, N for Norman. So it's the 4 to 12. And I have found that the higher voltages do work better. You get, obviously there's more headroom, isn't there? So you can make it louder basically. And it works fair enough. You get a voltage gain by default. If you just connect up the minimum amount of pins on here, you'll get a gain of 20, which isn't an awful lot, to be quite honest. But as it says on there, the voltage gain is anything between 20 and 200. So by the simple use of a capacitor between 2 pins, it will go straight away to 200, and if you put a resistor in series with that capacitor, you can have it infinitely variable between 20 and 200. Sounds all right, doesn't it? The quality of the sound is so-so. You know, it's okay for radios and stuff, like it says here, and little tape players and all that. And certainly for this, it would be absolutely ideal. The frequency range would easily cover up to 22k. So I thought, right, well that's an option then. I could use this, and TI, God bless them, they've actually put the schematic of the actual device here, which is great, so you know what all the pins are doing, And if we scroll down a little bit, they give you some circuit diagrams. So here's the 20 gain version with the minimum pin connections. Right, that's fairly straightforward, but we want more than 20. So if we scroll down a bit more, so here's the LM's 386 with a gain of 200, and all it's done is added this capacitor in here. Right, so that's pretty good as well. And further down again, they show you the gain with 50, because all they've done is put a 1.2k resistor here in series with that capacitor. So that sounded like a possible goer, frankly. Minimal component count, really easy to do. 200 times amplification from an electric microphone could work, just about. So that was an option. And remember, the output from this audio module, we're feeding in to a microcontroller, probably a nano or Uno, something like that, on one of the analog pins, because we want to detect the bark. Okay, so if you can imagine, a bark is a single woof, like a hand clap. It's got to last for a particular time, and then it's got to be repeated again to sort of, so that we can have some intelligent switching. We don't want to make the poor dog, think he can't open his mouth. That's not the point of this at all. So this is the Arduino that's going to provide the intelligence, but this has got to be it's got to be repeatable and consistent in its behavior, not, for example, detect a bark 1 second and then not detect it another. Okay, so I think that would work. Then I found this little one here. Now this uses the LM386 in exactly the same way as we said, but it is the minimal component count module that this has got. And what it's got, I'm going to get my pointer out now. Okay, so on here then, where it says R1C1, that was the series resistor and capacitor that joins pins 1 and 8, so you can make it far more sensitive. And I can just drag one across my workbench. You'll see that, in fact, I've already done some of this work. So what a mess, eh? So I've just put a capacitor across here, another one down here which is on the bypass pins. I've tried something else here. All per that data sheet. It's not like I'm doing this blind. I've got it connected up to this electric microphone, and that works reasonably well. I've got to say that's pretty good. It gives a decent output and it's consistent and repeatable. So that could have been a contender, and still might be for all I know, until I discovered, oh, let's have a look, this one here. Now this is just a microphone preamplifier, and it uses a different chip altogether. Now this uses the Max 4466, I believe. Yes, 446. In fact, it says it on the back. No, I'm guessing. There we are. Max 4466. Now that's a low gain. No, it's not. It's a low noise, high gain preamplifier. You can adjust it a bit on the back here with that variable resistor bit, and it requires 3 wires. So you got your power and your output. Now that says anything from 2.4 volts to 5.5, so that's within the Arduino range again. And I thought, oh, now we could be talking a solution here. And yes, I've done some experiments on this as well, and this gives us quite a nice range. So this can be, I don't know, 3, 4, 5 meters away from little Dougle when he barks, and it'll still pick him up quite nicely. And the output pin can actually go to the full voltage range. So if you've got a 5 volt supply, you'll get a 2.5 peak one way and 2.5 the other. Quite nice. Now we can use that either directly into an Arduino pin to detect the sound, or rectify it, have some sort of peak detector circuit, which I'm considering at this time. Maybe the Arduino will do it anyway. So let's have a look on the oscilloscope then, as this is on our short list of 1 at the moment, and just see what we get out of it. Right, so it's connected up to the oscilloscope now, as you can see in the bottom left hand corner there, and it's picking up my voice. As you can see, the waveform is changing. I've got it on a particular setting, so it's sampling every so often. Now this is just normal conversation, but look what happens if I clap my hands in a sort of a bark emulator. Now that is very different, isn't it, to what you can see on the screen now. The difference between this normal conversation and that is huge. And I'm thinking, do you know what, a Nano or an Uno or any microcontroller is going to detect the difference in that, no trouble at all. In fact, the voltage goes from, what does it say there? It's saying it's between about 200 to 400 millivolts at the moment. If you look at that one there, and when I clap my hands, we are 2.6 volts it says, if you saw that very quickly. So the Nano is going to find that, no trouble at all. Now of course I've also tried to do more than just clap my hands. I've woofed and all that. No, I'm not going to woof here in front of you, sorry. Alright, just once, as though this was Dougle barking, right? Woof! There we are. 2.5 volts in fact, that one. So I've been experimenting. I know, I might cut that bit out actually, it's just too embarrassing. But anyway, I've been experimenting like this. I've obviously got to experiment at some point with Dougle barking to see if I can capture it, but I think it's going to be okay. But the point is, having now got a device that does manage to pick up the sounds pretty good, even from a distance. I'm quite close to this. I'm probably about, what, 50 centimetres away, a foot and a half. As I say, Dougle could easily be 3 metres away, but then he is loud, probably louder than what I was, well, either barking or even clapping my hands. So I'm hoping this will pick it up no trouble at all. And if it doesn't, if for some reason we discover it's not quite sensitive enough, I could always boost it via LM386 or something like that, right? But that's something for the future. I think the critical bit now, though, is to get the code running, or at least working with me clapping my hands and barking it, so that the idea is he barks once, he might get a little tiny whisper from that device there at the back just to say, oh, sorry PCBWay, didn't mean to move you, just to say, oi, watch it, you know. Or maybe the first one is for free, so nothing happens. But if he barks again within a certain time span, so barks once, maybe a second or half a second delay, and then he barks again, then he'll get a warning shot across the bows, as it were. And if he barks again, then it will turn on for, I don't know, 1 or 2 seconds, and so on, up to maybe 2 or 3 seconds at a time. The idea, of course, is that it doesn't cause him distress in that way. It just causes him like, what's that noise? Why am I hearing this awful noise? A bit like us having a fire alarm bell go off. Where I used to work, they used to have fire alarm bells there, and they were so loud that what people did, they actually got tissue and they stuffed them into the little siren just to bring the noise down to a normal warning level. It was ridiculously loud. I mean, yeah, there might be a fire alarm or a fire going off. The fire alarm goes off and we all end up sort of temporarily deaf because this was so stupidly loud, especially in the stairwell. It was nonsense. Anyway, so I don't want to do any of that with Dougle. This isn't, this isn't a punishment. This is a reinforcement of behaviour. So I reckon that microphone, this output, a Nano or something in the middle there, it's going to work pretty well, I hope, if my code is right. And of course the code can be very simple to begin with, and we build upon that. A couple of sensitivity controls on the front panel, and perhaps an LED or something to show it's on, although you can hear it. Now if I turn this on with 12 volts, I'm pretty sure my microphone will pick it up. Whether or not it gets picked up on the actual video itself, but I'll turn down the frequency if it doesn't, and maybe you can hear it. Let me do that next. Okay, the oscillator's running, and as you can see from the scope there, it's generating this pulsed waveform. It won't lock onto it because it keeps changing in frequency, but I can hear that because it's going up and down. Now I don't know if my microphone is actually picking it up or not. Yeah, it is. The microphone's picking it up. As I say, whether it gets onto the final video or not is another matter. Let me turn it down just by turning this. Now the microphone's actually overloading now on that sound, but you get the idea. If Dougle, our dog, can hear that sound but at a higher frequency, I think that's enough to teach anybody. If you bark, that's what you get for a bit anyway. It should shut you up. Well, the proof is in the pudding, as they say. We'll see how far I get. The next step is to make a simple sketch for this then, isn't it, really? And put it all together on a board or something just to prove that it's going to work. Proof of concept's always a good thing to do. And I'm sorry, I've got to turn this off again. Right, I can't hear that now. I don't know what frequency it's running at, but it's too high for me and too high for the microphone to pick up now. Okay, the next thing, sketch, and we'll see how well it works. Right, here's a sort of a prototype bit of code, a sketch, just to prove that I'm on the right track really. So you can see from the window here, at the moment it's just displaying something here in the debug window, the serial monitor. It's saying there's a quiet period, which means a quiet period means 15 seconds of non-barking detected, and it just resets everything. When I say resets everything, what I'm going to do is count the number of barks in any particular period and increment what happens on the ultrasonic side to a fixed level. We don't want the thing to go bananas. So that's what it's saying at the moment, although it doesn't do that. But what it can do, if I clap my hands, you'll see that it will detect bark. Now when it says new bark detected, obviously the waveform is not a sudden one peak and then down to nothing. It oscillates, so it will continue to sample. Remember, this is reading the analog port, probably, well, anything up to 10,000 times a second. So it's trying to track really that waveform going past. So just because at the instance of detection the waveform has gone down to sort of the zero, it's not a pure sine wave obviously, but you know, it'll go down to zero, it doesn't mean the bark's finished at all. It's still in that section. Now if I show you the scope as that happens, I think you'll get a better idea. So what I've got the trigger level set to on the scope at the moment is to avoid all the background noise, you know, just the analog noise, and if I clap, you see that it shoots up there. In fact, this bit here, that's where it's detecting it and then slowly going down because I've implemented a peak detector. What does the peak detector look like? It's basically a resistor and a diode. In this case it's a Schottky diode, very low forward voltage drop. And well, let's just do that a couple of times. You see that? Nice, so that the analog input now of the Arduino, it can detect that bark a lot easier whilst rejecting, well, the conversation I'm having now, for example. Let me show you the circuit diagram then of the peak detector, simplicity itself. In fact, let me show you the circuit diagram of the whole thing that I've got on my bench. So what we've got here then, that's the microphone module that I showed you earlier on. We're going through a capacitor because I think the output is DC coupled at the moment. We don't want DC on here. Through a Schottky diode, I'm using the 1N5817, which is a very low voltage, low current, well, 1 amp current capability. Not that we need that. Now the charge pump is actually this diode, this capacitor and this resistor. Now unfortunately things are going a little bit odd with that, because the formula as I know it should be 5 times R times C, and that should give you the decay rate of this. Now I've tried 0.1 microfarads and a 10k, which should have given me 5 seconds, and I expected, okay, maybe a little bit less because I don't know what this is connected to inside here. Maybe there's another resistor in here or something, who knows. But it was pretty slow actually. So I've upped it now to a 1 microfarad and 100k, which in theory should give me 50 seconds I believe, but I don't know, perhaps one of you guys can point me in the right direction. But anyway, that gives this the nice sort of slope that you just saw on the oscilloscope, and that's enough for the Arduino to detect, well, more than enough for the Arduino to detect a descending slope, so that the bark period is not just a sudden peak of, you know, 1/10 of a second. It really does work out nicely. So that's the circuit diagram of everything. Now the code itself is a work in progress, I've got to say that, and it's going to take a little bit of time before this is totally correct. I've got to count the number of barks, turn the ultrasonic on just for half a second or maybe 1 second, and then increase that up to a period of, I don't know, maybe 15 seconds tops. Absolutely, it might even be less than that actually, because as you heard from that previous bit of the video, which I've just edited, I'm really sorry about that, guys. That was much louder than I thought it would ever be on the video. I've tried to reduce it using an equalizer, but it was painful. So I don't want to cause distress to poor old doggy. I want to just make him aware that barking is not a good thing to do. So we might have to reconsider exactly how loud this is going to be. But anyway, I only want it up to a maximum of say 15 seconds, maybe even 10, and then say, right, you've had enough, I'm just switching off now for 15 seconds, letting you calm down a bit, and then we'll restart. A bit like what it's doing now. It says quiet period detected, it might say timeout period, and just reset everything, wait for 15 seconds and start again. Because after all, it's the repetition, the reinforcement over a period of weeks that will probably get him trained not to bark at the postman for 2 minutes at a time. Okay. Now there were some alternatives I looked at. If we go to the browser, there was this kit available from Banggood, only £2, and I thought, well, why reinvent the wheel then? If it's already available, let's get it. But I thought, oh, hang on a minute, this is a clap switch. So what happens is you clap once and the LED or the output goes high, and then it has to clap again to make it go low. Now they did provide a circuit diagram. There it is, there's a circuit diagram of it. And I thought, well, I could potentially change this monostable into a bistable, change this resistor into capacitor and whatnot, and fiddle about with this. And I thought, well, stop. This is not the right module for what I want. Yes, it's got a little amplifier here, but as we've seen, amplifiers, microphone amplifiers are easy to make or to buy or build or whatever. So I thought, no, not quite what I want. Pity, because I'd have loved to have made it, because it's one of those little circuits, little bits. Nice, easy beginner's circuit for a clap switch. So if you're after something to turn your lights on and off, then this could certainly be a starting module, and that could feed into a solid state relay or something, just like we looked at in that video there on screen now. That could easily probably trigger it, I'm pretty sure. So it's a nice little kit. But anyway, not for me for this purpose. So what else did I look at? Now here was another option, not this one on screen at the moment, that's the one I've actually got. But as it happens, I also have another module, would you believe, which is not that one there. It is in fact, let's go back. It's a higher powered one, this one as well. So this is a higher powered one. Comes with a speaker this time. But unfortunately it's attached to the wall of my house at the moment, which means I'll have to get the ladder out and bring it down. I think, let's not go there. Right. That's sort of about where I've got to now. When I get this onto a board and get it a bit more worked out exactly how this is going to operate, I've got to have some kind of LCD screen perhaps, or just LEDs just to let me know what's happening. I'll show you again in a future video, but for now that's what it is. I'll be interested in your opinions actually about this whole ultrasonic thing, because I just had a quick look on the internet, and apparently it divides the opinion almost equally. Like, obviously people don't want things like collars because the ultrasonic is very, very close to the dog's ears, but this one's going to be up on the mantelpiece or something like that. So I'll be interested to see whether A, you've ever got it to work, B, whether you agree with it, or C, alternatives that might work as well. I can't think of any, but there we are. We're not having any shock collars or anything like that. Citronella sprays. We don't really want to put anything on a collar, okay, because that then makes him think that the collar is a bad thing, and it's not, obviously. Right, and as my oscilloscope's just gone off, that's just warning me that time's up. So that's where we're going to leave it for now. Thanks for watching. Appreciate your comments. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.